Hello everyone. Today we will see the design of pile groups. At this site, the number of piles are not known. What's the known parameter at this site? Load that come from superstructure on the pile foundation, that will be known to you. Let's say the safe load from the structure that is going to come is known to you. Let's say it is 2000 kilonewton. And the ground properties will be also known to you. Ground properties, as you know, it's cohesive ground. So Cu is known to you. It's a soft ground. And uniformly to very deep depth, it is going to be uniform cohesive soil with Cu equal to 30 kilopascal. Now, in order to design the pile group, how will you proceed? There is the information that you know it, alpha value, let's say it is 1. So first of all, we should find out the ultimate load. That the group is to carry. So this will be the safe load multiplied by a factor of safety, which is going to be 2.5 or 3. So QUG is going to be 5000 kilometers. Now for this, we will have to design the pile group. So based on individual shear failure, the ultimate load carrying capacity of pile group is given by this equation. So we are going to have QUG in kilonewton, that is 5000. The number of piles are not known to us. We know the load and we know this. And let's say the available diameter at the site, the diameter of the pile is 1 meter. This is the availability of. So D is known to you. Now, unless you know the number of piles and the configuration of the pile group, the pattern of the pile group, you cannot find out eta G. So how to proceed? You will have to assume initially that eta G is unity. This is our first assumption. So assuming eta G as 1, and number of piles can be calculated, and the ultimate load carrying capacity of a single pile, as you know, is going to be alpha times Cu into pi dl plus 9 times Cu into pi by 4 ds square into 1. Now, if you calculate this, alpha is 1, Cu is 30, pi, d available at the site is 1 meter, whatever is, and initially assume the length of the pile in order to calculate the number of pile required. Say we assume the number of, length of the pile as 10 meter. So there are two assumptions. So we assume initially eta g equal to 1 and length of the pile equal to 10 meter plus 9 times Cu into pi into ds square divided by 4. Therefore, you can calculate the number of piles required. So, if you calculate this, is 300 pi plus 270 into pi divided by. So this is going to be, this whole quantity is calculated as 1154.5 kilometer. So this has been calculated. Therefore, number of piles equal to 5,000, the ultimate load carrying capacity of the pile group, divided by 1154.5. So number of piles required is equal to 4.33 piles. This is the required if you have to transfer a load of 5,000 kilonewton, the ultimate load carrying capacity of the pile. So because you cannot make 4.33 piles, let's select a pile group of 4 piles. So let's let us select n equal to 4 square pattern. So if it is going to be a square pattern, naturally you are going to add in the pile in this fashion. So 4 piles in a square pattern, 2 by 2. So the sectional view is going to be like this. This is the ground. And this is QUG. Once you fix up the number of piles and the pattern, a square pattern is known to you, therefore you can calculate eta g. Eta g you can calculate by Felt's rule. Say we apply eta g, we apply Felt's rule. That's the simplest way of calculating it. So how many interactions each pile is going to have? 3 interactions. So each pile will have 3 interactions. So 16 minus 3. What is the total number of piles? 4. So 4 into divided by, it is 1 by 16. So 4 into 16. So it is going to be 13 upon 60. So from Feld's rule, the group efficiency factor is 13 divided by 16, that is 0.812, 0.812. You can also use converse Leverage formula. You will be getting very near to 0.8, 0.79 something. So not much difference whether you are using Feld's rule or you are using converse Leverage formula. So once the pattern is fixed, I am in a position to calculate eta G. So eta G is now known to me. Total number of piles have been fixed to 4. Now, what should be, the diameter is also available, that is 1 meter. So what should be the length of the pile so that it carries the ultimate load of 5000 kilonewton. So now you can substitute and find out the values. So if you substitute now, this is 5000 kilonewton. Number of piles 4 fixed now, and this will be alpha times Cu into pi into d. What is the length required? That we will have to find out. The required length. So L pi dl plus 9 times Cu multiplied by pi d square by 4 whole multiplied by group efficiency factor, which is 0.812. So finally we are coming to this. Therefore, the required length, L equal to, you can solve this equation and you can find it out. So how will you do that? Let's see that. 5000 5000 divided by this gives you 6000 divided by 4 also. Divided by 4 equal to 1000. So going to be 1539.4. So 5000 divided by 4 into this is going to be these quantities. So this is going to be this is 1539.4, therefore 1539.4 equal to 35 L plus 275 270 212. This, if you calculate, is 212.05. So finally, therefore, L can be calculated. 1539.4 divided by 40 into is equal to 14.08 meter. So what is the required length? The required length comes out to be 14.08 meter. Therefore, provide L equal to 15 meter. You can provide it more than what is the required. So provide L equal to 15 meter. Diameter is already known to you, 1 meter, and number of piles equal to 4. Now you will have to check it for block shear failure. So based on ISF, we got number of piles 4, diameter of the pile 1 meter, length of the pile we are going to provide 15 meter, and we will have to give a check for block shear failure or group shear failure. So we are going to calculate we know QUG equal to perimeter of the group multiplied by length into unit skin friction plus area of the group multiplied by QG. So perimeter of the group here we can calculate. So diameter is 1 meter, so VG will be equal to 4 meter. Width of the group will be 4 meter. Center to center distance will be 3 times D, so 3 meter. D by 2, so it becomes 1 meter. So 3 plus 1, 4 meter. So width of the group is going to be 4 meter, and therefore the perimeter of the group will be 16 meter. So 16 into length you have provided 15 meter. Unit skin friction for block shear failure is taken as CU. So CU equal to 30 plus the area of the group will be width of the group into width of the group for a square pattern. So width of the group is 4 meter. So 4 by 4, that is 16 square meter is the area of the group, multiplied by 9 times CU. So if you calculate this, we are going to have we are going to have 11,520 kilometers. So based on individual shear failure, all the requirement have been calculated, and now if I am giving the check for block shear failure, I am getting here, this is greater than 5000 kilometer. And therefore, the pile group based on individual shear failure, whatever we have designed is correct. So it is safe. In block shear failure, it is not going to fail, it is going to fail at lower load of 5000 kilometer. So whatever we have designed based on ISF is going to be correct. So final design therefore, so greater than this, okay. Therefore, the final design of the pile group is going to have N4 be 1 meter and length of the pile equal to 50 meter. So this is the final design. Thank you.